Good morning. So last week we talked about constants in an experiment, and we'll begin today with discussing what a control is. A control is often confused with constant, but it's different because it's a way to compare your treatment to a group that is basically left the same in an experiment. So we use a control to compare to see if an experimental group has had any noticeable change. Then we need to think about the materials and what we're going to need to do this experiment. One of the things as we structure experiments in this class is we have to be realistic as to the materials that we have, and we may need to modify our question accordingly. Our procedure is generally going to be a numbered step-by-step list of um, steps to take to complete the experiment. And usually in your procedure, you're going to want to write somewhere how you're going to do multiple trials. Multiple trials increase the accuracy of the experiment and reduce the possibility of chance errors. Now, as we're collecting this data, we can collect qualitative data, which are things like sight, touch, smell, and our sense of hearing. And those are all great. Or we can collect quantitative data, which are things like numbers primarily, so measurements. And these are great because they're not as opinion-based. Um, they're more objective, and basically they're fact-based. So if we can, we would want to design an experiment to use quantitative data over qualitative data. Now here's what a sample data table might look like. And I'll talk about this in the context of our algae growth experiment that we're completing this week. So let's say that my independent variable in the algae growth is temperature, and my dependent variable is going to be the growth of the algae measured in grams. So I would weigh the algae when we're done. The first column will be the value at which you change the independent variable. So this would be the temperature. And if I'm going to want to do multiple trials of the independent variable, I would have three different values for maybe room temperature, maybe a little bit warmer, and then maybe even a little bit warmer than that. And for each test of temperature, a best experimental practice would be to do multiple trials of that same independent variable. So if this is a test tube room temperature and we're growing algae, well, maybe I'll do 3 test tubes to increase my validity and certainty. And here would be 3 test tubes slightly warmer, and then here would be 3 test tubes at the warmest temperature. With our constraints in class, we're just going to do 1 test tube for each change in our experimental variable. Over here is a column for a derived quantity, and probably the most useful thing to put here is an average. So if I did have 3 test tubes that had been grown at room temperature here, and these values were the final mass of the algae, I might average that mass to produce one data point, an average mass at room temperature. And those will be the values that you want to include as you graph the data. Let's stop here. So when we make graphs, our graphs should be a reflection of our data tables. A graph should always have a title. It should always have a y-axis and an x-axis. On the x-axis goes the independent variable, and on the y-axis goes the dependent variable. And in our example here, our independent variable was temperature of the growth of the algae, and our dependent variable was the biomass or the weight of the algae after 1 week of growth. And if I think back to the data table, I had as my data point, I had an average mass corresponding to a temperature that was changed. So I might have 3 data points on this graph. The first one would be the room temperature algae, and we would chart what the mass was of that algae after 1 week. My second data point would be the increased temperature, and then we would want to have the mass there, the average mass. And then my final data point would be the really warm temperature and the average mass of that algae group. And so ultimately, you just have 3 data points to create what's a line graph of this data. So a question I get a lot of the times is, well, what kind of graph should I use, Mr. Lin? Well, generally, we're going to use 2 types of graphs in this class. We're going to use either bar graphs or we're going to use line graphs. And to make that decision, we have to ask, is the data discrete or is it continuous? Continuous data is basically just measurements, meaning I could have a value in between 2 data points. Discrete data is categorical data, like days of the week or color or a brand of battery. And so in this experiment, if we're thinking about temperature as an independent variable and the mass of the algae as my dependent variable, we would use a line graph for this sort of graph because there are values that could exist between the different temperatures, and there are values that could exist between the different masses of my algae. Okay, so ultimately our goal this week is to write the beginning of our first lab report. And you'll find the lab format that I'm looking at in the course materials area, the Files tab on Teams. And you should type this and begin your work this week all the way up through procedure would be a good goal. You won't submit it this week. We'll do that next week after you collect your data, graph it, and then make a conclusion. So you can see the format I use has different sections. Each section is worth a certain amount of points. And let's kind of go through this using the example from the video here. So my title would be the effect of temperature on the growth of algae. My purpose is to design and conduct an experiment and also to learn about the process of eutrophication. My problem statement would be, how does temperature affect the growth of the algae? My background research would be a paragraph about eutrophication and why it's a problem in stream systems. My hypothesis would be, if I increase the temperature of the algae or the water, then the algae will grow more because, and you have to use your ideas here to try to explain your hypothesis. Refer back to your background research. What do you know so far? Then we have our list of materials, things that are needed. So a test tube, spring water, algae, and then thermometer. If you're going to use a treatment of fertilizer, that would go in your materials list. And then the procedure is a numbered step-by-step list. So this is a set of directions. And this should be clear enough that you could give these directions to a classmate and they could follow them and complete this experiment. One thing I look for in here is an identification of the control and the constants as needed in this experiment. So what are the things you're keeping the same? Are you comparing to a control group? In this experiment, I am going to run the control group for the class at room temperature with no treatment that you can compare to. Then we would collect our results in a data table like we went through, except we will just have one test tube for each change in our independent variable. And then we'll make a graph, and I'll help you with that next week. Complete some observations, and then tell me what you learned. Accept or reject your hypothesis. Use this format, claim, evidence, reasoning. So the key to these science experiments is you're going to make a scientific claim about the relationship between 2 variables. So this is going to be your independent and your dependent variables. So let's say that the warmer temperatures did indeed show an increase in the growth of algae. We would say that in our claim. Our evidence would be based on our data that we collected, and so we would need to refer back to our data table and use numbers in our writing to support our claim. And finally, we would use some reasoning. So the reasoning is why. Why do you think this happened? Why does the increase in temperature lead to an increase in the growth of algae? What's going on there? It might have something to do with the process of photosynthesis, also possibly the nutrient load into this stream system. And then we want to think about how can we do it better? Where would error creep into this experiment? What would we change? And those sorts of things. All right, good luck.